All right, so let's talk about mixers. So with mixers, there are a lot of names for what a mixer is, but the basic idea is that it gives us full volume, it gives us full control over volume, tone, blending, and panning for a bunch of signals. So we have a bunch of inputs, and then we can control how they go to a bunch of different outputs. So there's a bunch of names for what this is. I'm calling it a mixer. It's also called an audio production console, and it's also called a desk, a board, etc. There are a bunch of names for it, but it's like one of the major tools, especially in live sound. But in all software, we have also versions of mixers. Somebody on the chat is asking about impedance. Impedance is a medium's resistance to sound traveling through it. Yeah, impedance does have to do with the amount that a piece of equipment resists electrical flow. Yes, correct. But we're not going to talk too much about that right now. So mixers. Mixers are usually used for monitoring in different ways. So let's say we're making a recording session, we're doing a recording session, or we are doing live sound for any context. We have different mixes for different purposes. So basically, you have a master mix, and that's for whatever's coming through your main speakers. So if you're in a club, let's say, then that's the PA. If you're in a recording studio, then that's the speakers that are in front of the engineer. You also have speakers for people on stage to listen to, which are called headphone mixes or monitor mixes. And then you also have any other mixes that are of sounds being sent to software. This Mixbus software keeps making noise. I'm going to mute that. So in addition to those different mixes, we have what's called busing and grouping, which should sound familiar. So this is doing an aux. So an aux send is the same thing as a bus or as a group or as a submix. So mixers can take a bunch of inputs and send it to a bunch of outputs, and you have control over that in different ways. So if you understand one channel strip, then you understand a mixer, basically. What we have on mixers is, if you look right here, we have a bunch of strips that are numbered. So in this case, we have 16 channel strips, and they're all, as you can see, the same. So if you understand how one of them works and how the signal flows through it, then you understand the way the mixer works. So here are all the possible things that you can have in a mixer on a channel strip. Usually we have something more like this. Channel input, a gain knob. Sometimes you have an insert. You have an aux send section and an EQ section. Often they'll get switched around. A pan knob, a channel fader. Sometimes you'll be able to change where it gets sent, sometimes not. A master fader, level metering, and the master output. So let's look at some examples. So in this example right here, we start with an XLR input. This is also an input, a TRS input. Right here is a low cut, and right here is the gain knob. Next we have the aux send section to send not to the master fader but to extra outputs, the auxiliary outputs. We have an EQ, a pan knob, a mute button, a solo button, and the gain knob. So the way that the signal goes through a mixer is it comes in on the input side, it goes over to the output side, goes through the main output and out. So this basic flow is the case in every different type of mixer. The inputs are usually on the back left of the mixer, and the outputs are usually on the back right of the mixer. So let's talk about each of the different parts of the mixer one at a time. Different parts of the channel strip. And I'm going to minimize this a little bit so I can pull up some other stuff. So every time you plug in a device into a mixer, so like right here is a TRS input, anytime I plug in a device to a mixer, the signal is already being boosted. So every time you use a mixer, the signal will be boosted by a certain amount. And then the gain knob, the actual little knob that you have on the mixer by the input, controls how much is the gain being boosted or cut. And you have two different inputs. So line input will be basically stronger, so you might want to even take that down, whereas a mic input will be generally weaker, so you're going to have to boost that a lot. And the important thing about the preamplifier is that it matches, this actually has to do with impedance that we were talking about earlier. It's used to match the output level of a microphone so that they come into the mixer at a good level. If we look at our software mixers, so this is the Harrison MixBus 5 software, and I can also pull up Logic to the mixer window. Ooh, I clipped. Usually for the input and the gain settings, those aren't really going to be in our software. And if you think about, so I have gain reduction, that's cool. Never use that. Usually we're not going to have that. And if you think about why that is, that's because all of the actual input gain settings have to happen in an interface. They have to happen in a separate device in order to be used on a computer. So if I pull this up, let me pull up an audio interface on Sweetwater. So if you're using digital audio and you're putting sound into a computer to be recorded, then you have to use an audio interface. Ooh, cool. So let's say you're using this solid state logic USB interface, which SSL is a very good brand. Then in this case, all of the input gain settings, you plug something in to physically into this interface, and then you can control the gain level of it using the knob and using these different options here. And then that's going to go into Logic or into whatever DAW you're using and be controlled. So actually in software, we don't really have this stage because this has to happen outside of software most of the time. Likewise, in software, we don't usually have insert points. This is a special thing that's mostly used in live sound and in physical devices. And it's basically a loop. So it's a break in the signal chain where you can send something to an effect and have it loop back. And it actually requires a special insert cable that is TRS on one side and stereo TS on the other side. We use something like this for if you're playing something from your phone. We use a 3.5mm TRS to stereo TS. But the way that these special ones work is that into the mixer you plug this TRS, and then you have two different sides to plug into, let's say, a reverb unit, one to the input and one to the output. And it creates a loop that goes just with one connection. So it's kind of a special thing that's mostly used in analog. Now this is something that's true for both analog and digital mixers, an aux send section. So this is the part of the mixer that's really important. It's used to route and send signals from one input or output into another one other than the master. So this is used to create submixes. This is really important if you're doing, especially for mixing. Let me give you an example. So like right here in Logic, this is a session that I just recorded for fun. I'll play a little bit of it for you just so you can get a feel for it. in this case, in this session, I have, this is a guitar track. I have a bass track, and then I have a solo guitar track. And then I have a drummer track, which is a special kind of Logic thing. And then I have this, which is an auxiliary track, whose input is bus number 1. Stereo out, which is actually my master, and then an extra master fader, which is basically useless, as I understand it. So let's say I wanted to group together a couple of my tracks. Like, let's say my 2 guitars, I want to put an effect on both guitars. We've talked about this before. I can use parallel processing by creating a bus. So I'm going to do that. I'm going to do a send in my auxiliary section to bus number 2 on both of my guitar tracks. So now in bus number 2, I'm going to call this guitar bus. And on this guitar bus, I can put whatever I want to affect both my guitar tracks. Let me think about what I want to do here. I'll do like some pedal board thing. So now let's just listen to those guitar tracks together. Okay, that's good. So if you look at how this actually works, I have my 2 tracks. Each of these tracks are going into the master. So I have my inputs, they flow over to the master and out. And then separately, through a bus, they're both getting sent over to this guitar bus. And then in that guitar bus, I have some effects. So I can control the wet versus dry, the affected versus the not, by this being the affected signal and these 2 being the dry signal. So let's mess with that. So if I turn the bus all the way down, I have clean. If I turn the bus up, I have affected. If I turn these down, if I turn those down, then I only have my affected signal coming through the bus. So the bus acts as a separate send, a separate group of tracks that I can then mix or do different things to. I can add effects or whatever. So the bus, the auxiliary send section is really important. And for example, if you have a send for each different person on stage, let me pull up a graphic of this. So band on stage. See what comes up here. This could be weird. I don't know. Band on stage, yeah. Okay, the Michael Vincent Band is the first band that comes up. Never heard of them before. I'm sure they're great. There they are. All right, so this is cool because we can see there's this speaker down here. This is a wedge monitor. This is a speaker that's a special mix that's made for the lead singer and guitar player to listen to. Probably there's also a speaker back here by the drummer so that the drummer can listen to it. I can't see one right now. So what you would do in your aux send section is you would decide, okay, on this mixer, the monitor that's going to, the send that's going to the lead singer is going to be send 1. So then in your session, you send only the things, on your mixer, you send only the things that you think the lead singer would want to hear. So this would be like the lead singer's mic. They definitely want to hear that. They definitely want to hear their own guitar. They definitely want to hear the bass. And you know, their head is like right next, they're pretty close to the drummer, so you don't need to send any drum signal to them. So you have a submix that's using the aux that's sent only to that one person. So this whole aux send section and making buses and everything is important in a lot of different contexts, and you can use it creatively. So let's look at another mixer. So this is a Behringer X1204 USB mixer. And this is slightly different than what we looked at before. We've got an XLR input. I'm actually gonna make this bigger. There we go. So we have an XLR input, and we have a line input, a low cut, and a gain knob. This right here is different than what we've seen before. It says comp, and then it has this little curve thing. So if you recall back to our DSP, digital signal processing talk, you could probably figure out that this is a compressor. So this is an effects loop that's already programmed in, and actually over here you can control this multi-effects unit. Now, unless you're using a really nice mixer, I don't recommend using effects that are built in on a mixer. They usually are not going to sound very good. We have a selectable frequency EQ unit, an aux send section, which is just 2 sends, one of which is earmarked for the effects loop. So the effects over here that you can set. A pan knob, a mute button, a solo knob, and our channel fader. So after this, it would go over to the main mix. It would be sent into our monitor, our LED monitor there, and then it will go out of our main output, which is on the back over here. Let's take a look at the mix bus. So this is a model of this quite well-regarded mixer, the Harrison Mix Bus console. Oh yeah, don't mind if I do. So Harrison mixer. Yeah, so Harrison makes these broadcast and other types of mixers. Yeah. Oh man, that looks awesome. So free local pickup. And they have software that's modeled after these analog mixers that they have. So this one's looks like it needs a little bit of love. And this software just models that. So if we look at what we've got, we have an EQ section. I'm going to zoom in a little bit. We have an EQ section, which can be punched in or not. And then we have a bunch of different buses. So these buses can be added or subtracted. So this is a pretty flexible aux send section. Then we have panning. And the panning, you can actually change which mix you're going to. And you can choose to sidechain or not. We have a mute and a solo. Panning again. Being able to send to a compressor or not. The channel fader. And then that goes over here to our master fader. The master then goes into these pretty sweet looking meters here, these VU meters, and then out. So this is a pretty good software representation of the way that those physical mixers work. And they made this software to try to model exactly how those mixers sound. If you look at Logic, slightly different. The first thing that we have is actually our EQ section, which is kind of helpful. I really like how you can see the different EQs that are in. Oh yeah. I think because it's in demo mode, it does that. I like how you can see the different EQs here. Our input settings, our plugin section, our aux section, output selectors, groups, automation type. Here's a little logo that shows you what type of track it is. Panning, our different levels, and a meter, LED meter. Faders, and then all of our mute and solo buttons are down here. So everything's in a slightly different order than it was on the physical mixer, than it was in other software. So just to show you again that these are all the elements of a channel strip, but they can be arranged in different ways depending on what device you're using. So usually on mixers, EQ, on physical mixers, you're going to have limitations because you just simply don't have space to have a totally customizable EQ. This is a very nice EQ module by Solid State Logic, which is a parametric EQ, and it's really customizable. You can put EQ on a single channel, or you can also put EQ on a group or on a master. Usually for each mixer, there's a specified range for each EQ band, for each shelving filter or each peaking filter, and it's either customizable or it's not. So these are both customizable. The other ones we've looked at, like this one, is not customizable. So it tells you what frequency these are based on. You might have a dynamics section. So here's an example from Reason that has a dynamic section built in. A monitor section where you handle and change all of the different inputs that you have and where they're going. So this is a monitor section from a Mackie 1604 mixer. You can control the headphone level and a couple of different output levels. The channel fader determines how loud this thing is when it's going to the master. The pan pot determines the left and right position. Solo mutes everything except for the thing that you're soloing. If you're in a physical mixer, the mains will still be sent, but then just what you're listening to in the headphones will be soloed. If you're in a DAW, then solos both in the main output and in what you're hearing. The mute just cuts that channel out from the mains and the monitor. Output section, you have control over how loud each bus or each aux is and how loud the master is. Overall, everything added together. Channel assignment, your mixer might have this. You're controlling where exactly is this signal getting sent, which buses or to what. Grouping, if I send a bunch of things to a group, that's really useful. It has more limitations in terms of physical mixers because then stuff is just glued together. You can't unglue it, but it's still really helpful. The monitor level section, here's where we have our meter that shows us how loud is our signal, how much signal do we have compared to the overall output level that we can. Patch bays, these are to help prevent spaghetti monsters from coming into your nightmares, basically. This is a centralized place for all the inputs and outputs of your various devices. So let's say you have multiple mixers, or let's say you're in our studio at Stetson and you have all these different pieces of equipment in different places. You just connect all of them together into patch bays so that you can change the inputs and outputs really fast and really easy. So this is inputs and outputs, like basically, let's say 2,000 inputs and outputs, all connected together in a crazy way. So this is a really big recording studio that has a lot of equipment. Metering the signal strength. Oh yeah, these sweet VU meters, which are used for analog equipment. Oh, makes me feel like I'm on a submarine. And then some meters for a DAW. One thing that's different about metering between analog and between digital is that clipping means something different. So with analog, you want the level to be near 0, which on this meter is right kind of in the middle. Then it has all this stuff plus 0. So you want to keep your mix near 0, because if it clips, it's okay. It's going to sound nice, actually, probably. Whereas in digital, you want to keep the level away from 0, because if digital gets to 0, then it clips and the clipping will not sound good. So you want to keep the level much lower. So in Logic, if you look right here, clipping is at 0. Whereas if I go to my Harrison mix bus, clipping, I think because it's modeled after a physical mixer, well, definitely in the VU meters here, the loudness meter, clipping will be above 0 at plus 14. So know what you're mixing with and what the maximum level should be. So just to reiterate, this is the overall signal flow. You should be able to look at this mixer and tell me which elements are on this mixer and what order they're in from top to bottom over to the output side and out. So these are different configurations for how mixers can be used. The same mixer, this is, I believe, the 1202, a 12-channel Mackie mixer. So in this case, let's check it out. We've got a guitar input, a keyboard input, a mic input, all into the channel inputs. The inserts are going to this tape machine and into a processing unit. We have auxes being sent to some reverb and delay units and back in. And we have a tape machine, headphones, and main outputs. So if I had to guess what was happening here, I'd say that it's a recording session of 3 musicians: guitar, piano, and vocals. If we look at this one, we're doing something completely different with our same mixer, right? This is much more like we're in a club, we're probably making some hip hop. We've got a couple mics, we've got a couple turntables, a sampler, some CD players, and that's going to some PA speakers, and we have these Mackie logo people dancing. So in this case, the aux returns are being used completely differently. The auxes are going to some lights. The inserts are going to a compressor unit. And the alternate outputs, this is interesting, are going over here into a sampler. So what this does is that you can use the turntables, you can do scratching, you can connect it to different parts of the track that you want to hear on the turntable, and then you can send that into a sampler unit, sample it and play it back. So it actually has this loop back function so that you can make beats with it. This right here is definitely a live sound situation. We've got some stage monitors, we've got some speakers. In this case, aux number 1 is going into the stage monitors. So if you wanted the musicians to be able to hear something in their monitor, you should turn up aux number 1. So we've got some vocalists, guitar players, keyboard players, a drum machine. Our inserts are going to compressors. And our second aux is going into an effects process. Other than that, it's pretty straightforward. So you can use the same mixer in a bunch of different ways. Oh yeah. So here's a mixer cake to celebrate learning about mixers. I think some engineer got this for their 40th birthday. Pretty amazing. If you could make a mixer like this as a cake, then I will give you an A, because that's just impressive. All right, so that covers the different aspects of mixers. Just quit. Whenever you're working on your projects in whatever software you're using, pull up the mixer window and pay attention to the order of what it is. And use the PowerPoint in order to study and understand mixers better.